So let's look at some of the rules for exponential functions. I think most of you are probably familiar with them, but let's just go through them once more. So let a, b, x, and y be real numbers. All right, and ab would be greater than 0 and ab are not equal to 1. Okay, so the first rule we're going to look at is what happens if I did a to the x times a to the y. Okay, what would that equal? So let's take an example. So let's say I had 2 to the squared times 2 cubed. What does 2 squared mean? 2 squared means I'm multiplying 2 with itself 2 times, right? So 2 squared would amount to that, this one here. And then 2 cubed would amount to 2 times 2 times 2. So that would be 2 cubed, right? So in total, how many 2's am I multiplying? I'm multiplying 5 2, so I get 2 times 2 times 2 times 2 5 times. And that would be nothing but multiplying 2 with itself 5 times. And so that becomes 2 to the 5. Or I could think about this as 5 is nothing but 3 plus 2, so 2 to the 2 plus 3. So in that sense, a to the x times y is a to the x plus y. So that would be our first rule. Okay, and that is a to the x times a to the y is going to be a to the x plus y. Remember, you don't multiply the exponents, you add the exponents. Okay, so rule 2. Let's go ahead and explore the following. We want to explore what is a to the x over a to the y. Okay, again, know that a is not equal to 0, so I'm fine here. Let's again take a equal to 2. So suppose a was equal to 2. So I'm going to have, say, 2 to the 5 over 2 squared. Okay, so what does that mean for us? For us, this means I'm multiplying in the numerator 2 by itself 5 times. And then in the denominator, I'm multiplying 2 by itself 2 times, right? So I can cancel off these here. They cancel off. And so I'm left with 2 cubed. Okay? Or I could think about this as 2. Well, how do I get the cubed? I get it by 5 minus 2. Right? So I can think about this rule as a to the x over a to the y is a to the x minus y. So that would be rule number 2. Now let's take a look at rule number 3. And rule number 3, we're going to talk about a to the x, all of this to the y. So here, think about it, I'm raising an exponent also to an exponent, right? So again, let's look at 3 squared to the cubed. Okay, so let's look at what this exponent does, right? What this exponent does here is going to multiply 3 squared with itself. What is in the parentheses gets multiplied with itself 3 times. So this is going to be 3 squared times 3 squared times 3 squared. Okay, and again, what does the 3 squared do? Well, that is 3 times 3. This is 3 times 3. And then this again is 3 times 3. So all in all, I'm multiplying 6 3's, right? And how do I get the 6? I can think of as multiplying the 2 and the 3 here. So if I'm raising an exponent to an exponent, that gives me a to the x times y. Don't confuse this rule with a to the x times a to the y. This is a to the x plus y, right? And then a to the x to the y is a to the x times y. So make sure that you have a proper understanding of the differences between these two rules. Okay, so now we're going to take a look at what is a to the 0, right? So I'm going to make a table, and then let's make an observation from the table. So I have x, and let's say I have 2 to the x. Let's start with 4, 3, 2, 1, 0, -1, -2, and -3. Okay, and so then what is 2 to the 4? 2 to the 4 is 16. 2 to the third is 8. 2 squared is 4. 2 to the 1 is 2. So then what is 2 to the 0? What do we notice in these numbers, right? If you notice, 8 is the half of 16, 4 is the half of 8, and then 2 is a half of 4. So as I go down, I'm essentially dividing the numbers by 2, right? So 16 divided by 2, 8 divided by 2, 4 divided by 2. So the obvious choice here would be to divide this number by 2, and that's going to give me a 1. Okay? So I can think of this as a to the 0 is 1. All right? Now, let's continue this pattern. 2 to the negative 1. What is 2 to the negative 1? Well, if I divide 1 by 2, what is going to happen? I'm going to get 1 over 2. Or I can also think about this as 1 over 2 to the 1, right? If I did 2 to the negative 2, divide that by 2. If I divide a half by a half, I'm going to get 1/4, which is 1/4, and this is 1 over 2 squared. If I divide 1/4 by 2, I'm going to get 1/8. And so this is going to be 1 over 2 cubed. So I can think about the next rule here, that is a to the negative n is nothing but 1 over a to the n. Okay? So as in 3 to the negative 5 would be 1 over 3 to the 5th. Okay? The next property is, what is the xth root of a? Well, we can write that exponentially as a to the 1 over x, as in the square root of 3, right, can be written as 3 to the 1/2. Or say the 5th root of 4 can be written as 4 to the 1/5. Okay? Then number 7. Well, what if I had the xth root of a to the y? Okay? So that's going to be a to the y over x. As in, what is the square root of 3 to the 5? Well, then that's going to be 3 to the 5, and I can write the square root as 1/2, which makes it 3 to the 5 over 2. And then the final rule, we have a times b to the x. Okay? So this is going to be a to the x times b to the x. As in, if I have 3y squared in parentheses, that's going to be 3 squared times y squared, which is 9y squared. Okay? Although remember, a common mistake again here is when people do a plus b to the n is a to the n plus b to the n. That doesn't work. This is false. Let's take an example. If I had 3 plus 2 squared, and if I had 3 squared plus 2 squared, right? Now 3 plus 2, if I use my PEMDAS rule, 3 plus 2 squared becomes 5 squared first, and this is equal to 9 plus 4. We know 5 squared is 25, so what I'm getting is I'm getting 25 equals 9 plus 4, which is 13, and we know that cannot be true, so this doesn't work.